Limiting and excess reagents. This comes from Unit 3, and hopefully we're doing this on March the 19th. So let's go ahead and get started. First with some lovely vocabulary. A reagent is just a really fancy way of saying reactant. So if you see reactant, see reagent, they're synonymous. Your limiting reagents control the amount of product that is produced from a reaction. This means that you're only going to get as much as the limiting reagent will allow you to get. This is only going to be one of your reagents. All other reagents in a reaction are excess reagents. They are going to be left over at the end of your reaction. It's important to identify what your limiting reagent is because it tells you how much you may get theoretically if 100% of your reagent actually reacts. This does not happen very often. It's very rare. In order to identify what your limiting reagent is, you're going to use sort of stoichiometry with all of the reagents to find the smallest amount of a product produced. You have to use the same product when doing your stoichiometric conversions here because different products are going to be produced in different amounts. Let's work on an example with this. Copper reacts with sulfur to form copper 1 sulfide. What is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? Using the information provided, set up a chemical reaction and make sure that it's balanced. Pause the video and do this. All right, this is what I got. 2 copper with sulfur forms copper 2 sulfide. This is a synthesis reaction. We also need to make sure that our ionic bond here between copper and sulfur is balanced. Since sulfur has a -2 charge and copper has a +1, it will take 2 coppers to make sulfur happy. Therefore, we need to add a 2 coefficient to our copper. Very important to make sure that your reactions are always balanced. Now we're just going to set up our stoichiometric conversions. I'm only going to calculate to moles of our copper 1 sulfide. You can really start with either one of your reagents. I'm going to go in order and start with our 80 grams of copper. Starting with 80.0 grams of the copper, set up the stoichiometric calculation to get to moles of copper 1 sulfide. Pause the video. What I got was first, the molar mass of copper is used here. Our molar mass is going to be 63.55 grams copper to 1 mole of copper. We want to compare our moles of copper to our moles of copper 1 sulfide. We use our molar ratio, 2 copper, 2 moles copper to 1 mole of copper 2 sulfide. Before I do the math for that one, I'm also going to set up our conversion for sulfur. 25.0 grams of sulfur. Go ahead, set up your stoichiometric calculation. All right, molar mass of sulfur goes on the bottom. The molar mass is going to be 32.07 grams of sulfur per 1 mole of sulfur. We're then going to use our mole ratio to compare moles of sulfur to moles of copper 1 sulfide. As you can see, this is a 1-to-1 ratio. We are going to cancel out our like terms. So for our top, grams of copper cancels, moles of copper cancels, which will give our answer in moles of copper 1 sulfide. Down in our second conversion, grams of sulfur, moles of sulfur, leaving us again with moles of copper 1 sulfide. After we do our math, dividing 80 by 63.55 and dividing that by 2, we should get 0.629 moles of copper 1 sulfide. Down below, we'll take our 25.0 grams, divide it by 32.07 grams. We don't really have to do anything here because it's a 1-to-1 ratio, and anything divided or multiplied by 1 is itself. And that should give us 0.780 moles of copper 1 sulfide. The smaller amount here is our 0.629 moles of copper 2 sulfide. It comes from our 80.0 grams of copper. Because of this, we know that 80.0 grams of copper is our limiting reagent, and we also know that our max amount of product produced can be 0.629 moles of copper 1 sulfide. Here we see 80 grams of copper only produces this much copper 1 sulfide, becoming our limiting reagent. And it also means that our max amount of reagent is going to be, our max amount of product, is going to be 0.629 moles. Let's try another example. What is the maximum amount of grams of water that can be produced from the combustion reaction of 75.74 grams C2H4 and 201.6 grams of oxygen gas? Pause the video to set up this equation. Here's what I got. Remember, in a combustion reaction, we're always going to produce carbon dioxide and water. We are going to set up our stoichiometric conversions just like we did last time. So, using our 75.74 grams of C2H4 and our 201.6 grams of oxygen gas. This time, instead of stopping at moles of the product, I'm actually going to go all the way and find grams of a specific product being water. Pause the video to set these up. All right, so for our C2H4, we want to cancel that out using a smaller mass of 28.052 grams C2H4 per 1 mole C2H4. We're going to compare our moles of C2H4 with our moles of water using our mole ratio. This is a 1 to 2. 1 mole C2H4 per 2 moles of H2O. Then, because we're looking for grams of water, I'm going to continue this with our molar mass of water. We're going to cancel our moles of water and put our molar mass on the top. Before finishing this out with our math, I'm going to set up our 201.6 grams of oxygen gas. We're using our molar mass to cancel this out and convert over to moles. That's 32.00 grams of oxygen per 1 mole of oxygen. We'll come down here and use our mole ratio of 3 to 2. 3 moles oxygen gas to 2 moles of H2O. And again, I'm going to convert from moles of H2O to grams of H2O. This part is going to look the same as what we've already done at the top. All of our units are going to be canceled up until our grams of H2O. Leaving our answer in terms of grams H2O. And now we do our math. For the top example, we'll divide and then multiply. And then we are going to multiply again. This should give 97.286 grams of water. The bottom, we're going to multiply. Then we're going to multiply by our ratio of 2 over 3 and multiply by our 18.016. This should give us 75.667 grams. This 75.667 grams of water is the lower amount. Therefore, 201.6 grams of oxygen gas is our limiting reagent. And the maximum amount of grams of water that can be produced is going to be 75.667. Again, this means that we can make up to 75.66 grams of water if we have 100% yield. The next video talks about what this percent yield means.